So good morning, everybody. You may wonder why we come back in front of you to speak once again about fuel. And you may wonder why we have a presentation about fuel now, when the fuel price pressure is maybe less than it used to be. It's clear that if we look at the oil price on the last 5 years, we see that after a long period with very high prices, the oil dropped and it was divided by almost 3 on the last year. But if we zoom on the last period of time, from the beginning of this year, it has been multiplied by 2. So the fuel is fluctuating, the price of the fuel is fluctuating, and we can never predict what it will be on the coming months. So what is the purpose of this presentation? In this presentation, I will try to give you some elements to define on your own what is the best way to optimize the fuel on board, and especially to optimize the extra fuel you have on your aircraft. So to illustrate my speech, I will use a real example, a practical example, flying a 330 from Berlin to Montreal. And I will not give you a lot of figures with kilograms and pounds of fuel. I will use a new unit here. I will use some small jerry cans. So anytime I speak about a fuel saving, you will have a green jerry can. Anytime we have a fuel consumption increased, that will be a red one. So let's go on board and let's do the flight now. Let's take off. My speech, my presentation will be based on 4 parts. First of all, we will have some fuel data and basically a comparison about all the fuel saving initiatives you can have in your company and the cost of carrying useless extra fuel. Then we will discuss about the need of extra fuel. Do we need extra fuel or not? And if we all agree that on some flights we may need extra fuel, in my third part, we will see how to optimize extra fuel. So most of this optimization process will be on your side, but I will share with you some innovation or projects on which Airbus is working to help you to do this optimization. And finally, in the last part, which is very important also, we will have a look on the training and the flight crew training, flight ops engineer training to deal with this extra fuel. So, fuel data first. I'm quite sure that most of you, you have a very good fuel practices and fuel initiatives, fuel saving initiatives. Basically, we can group them in 2 types: green operating procedures and some flight management. So green operating procedures, you had a lot of presentation on that. They are now fully integrated in your SCOM. You can see on the screen some of them. It is true that every single procedure won't give you a huge saving, but if we combine all of them on our flight from Berlin to Montreal, we can expect significant savings, and we can have 4 jerry cans of savings on this flight. Another way to reduce the trip fuel is to work on the fuel reserves and using all the ways you have in your regulation to reduce the contingency fuel. So reduce the amount of contingency fuel, and for some specific cases where we are quite limited, we can also use redispatch or reclearance to reduce the amount of reserves. We can also, some of you maybe also decided to reduce the speed, targeting a speed close to cost index 0. That has a direct impact on the fuel, of course. And as you know, another way to reduce the fuel burn is to have a huge weight reduction campaign on your aircraft, trying to reduce the aircraft gross weight. So if we try to see what could be the maximum savings we have using this kind of procedures on our flight, we can expect almost the same or a little bit more than what we can have with green operating procedures. So why did I give you these values? Because now we will see what is the cost of carrying additional fuel. So extra fuel, I mean by extra fuel, fuel that you will put on top of the legal required fuel by your ops regulation. So before we look at the impact of this extra fuel on your fuel burn, I will spend one slide about extra fuel practices, recommendations, how to deal with extra fuel and what is the impact. So anytime you think that you may need additional fuel, the first recommendation is to, when possible, when time permits, request for a new computerized flight plan integrating this additional weight. The use of the corrections you have on your flight planning are good, but they are not optimized because they will not change your route optimization, flight level profile optimization, and you won't get at the end the best profile. So that will impact a little bit more your trip fuel. So by requesting a new CFP, you will integrate this additional weight in your performance computation. On top of this, it's always interesting to know why, as a pilot, you need additional fuel. So ask for detailed justifications to help to better understand your network and to see on which route you may really need some additional fuel. This being said, if we put 1 ton more extra fuel at Berlin, the impact on the trip fuel will be 2 jerrycans. If we put 2 tons, we will need 4 of them, of course, on your trip fuel. Don't forget that any weight increase at takeoff or may induce some additional costs on your flight. Higher takeoff weight means lower thrust reduction. The thrust reduction is also part of the savings you will have on your maintenance costs. You may have to use reversers at landing, brakes, so that's also something to take into account. So just to finish with this first part, basically, if you spend a lot of time to put in place some fuel savings practices, you have also to know that, and I'm sure you know that, carrying useless extra fuel may completely cancel the savings you have on the flight and may even change your savings in additional fuel burn. So, what about this extra fuel? When you have decided to apply or to use all the green operating procedures, flight management, and I'm quite sure that most of you worked on that, what is the next step? What could we do to minimize or to reduce the cost of the fuel during a flight? Here, the idea is to target optimum extra fuel as a function of the route, as a function of the flight, and reduce or optimize this fuel on board. But first of all, let's see why we may need extra fuel. All of you, you know that in your fuel computation, the fuel on board, you have the trip fuel, but you have reserves, a lot of contingency fuel and reserves. So why these reserves may be too low or not enough for a specific flight? To see that, I will say a few words about the definition of the contingency fuel as given in the regulation. Then we will see what's the purpose of this fuel and example of this fuel quantity on our flight today. So if we look at the contingency fuel definition, it's already given by your operational regulation, so it's not the same. It depends on your national authorities, but basically the purpose is the same. So this is what we have in the European regulation. Contingency fuel is here to compensate for unforeseen factors. So this is required. That's to cope with unforeseen factors such as weather avoidance, and usually it's given as a percentage of the trip fuel or percentage of the trip time. So the intent, the purpose is really to deal with uncertainty. It can be used during the flight, and it's not the only reserves you have on board. If you remember, you have also to carry the alternate fuel, the holding fuel. So from Berlin to Montreal, assuming a 5% trip fuel policy, we have with us today on this flight 20 jerrycans, additional fuel on the trip fuel. So why this jerrycan may be too low if we have some unforeseen factors on this flight? I'm sure that based on your experience, all of you have very good reasons to take some extra fuel on some flights because of the traffic, or maybe because of the weather. You know that on a given flight, the weather is not always as expected. Or why not? Because of your confidence in your fuel computation. You know that your fuel predictions, your computerized flight plan is not fully in line with the specific tail number you are seated in. And for all these reasons, you may decide to put some additional fuel on top of the contingency fuel. The question is, as you have already 20 jerrycans with you, do you really have to take 5, 10 more on a given flight? So all these reasons are very good reasons to assume that the contingency fuel may be too low. And we will see basically the impact of the traffic on the flight, the weather, what could be the impact on our flight from Berlin to Montreal, and then what could be the impact of aircraft performance model, which is not fully reflecting the real aircraft. So let's start with the traffic. Okay, the flying non-optimum profile, non-optimum speed, may have a huge cost. If we fly just 2,000 feet below optimum, if we are blocked 2,000 feet below optimum level, computed by the CFP, that will cost us already 12 jerrycans. Now, if we have a very long SID, whereas the computerized flight plan is using an average one, or a long approach, if we have some time constraints, if we have to do holding, or if for any reason we have to increase the speed because we want to avoid delay, and this is something we have more and more in real operations, especially in Europe, where passenger must be compensated for delay now. So if you have to increase the speed and avoid diversion or delay, that has a cost. And you see here, it's already a lot of jerrycans. What about the weather? The weather is basically the same. The weather will change your flight profile, or may change your levels, may change your route to avoid some threat, may give you some time constraints. If you spend time to avoid turbulence or storms, you may be late and you may accelerate. And the weather also can be different. The encountered weather can be different from the weather planned in your CFP, computerized flight plan. So we will have here something like 16 jerrycans. Aircraft model now. If the aircraft is not perfectly modelized in your CFP, or if the performance factor itself is not the correct one, the impact will be much lower, but it may have an impact on your fuel predictions. So this being said, now we have one more point here. Aircraft weight. If the aircraft weight is not very well known, if you make some assumptions on your passenger weight, and if your computation is based on a weight which is lower than the aircraft weight, that has also a cost on your trip fuel. Finally, when we look at this flight, Berlin to Montreal, and if we assume that we are in the worst scenario, taking all the bad conditions, this is not our day, and we have everything going wrong. If we look at the sum of extra fuel we may need compared to the contingency fuel, it's true that sometimes the contingency fuel is not enough. And we will have to think about additional fuel on top of the legal fuel requirements. So on some flights, for some conditions, additional fuel can be a must. Well, now we are in the main part of the presentation. How to optimize this fuel quantity? Optimize, first of all, is not suppress. When I say optimize, I don't want to say don't take extra fuel at all. Never. No, this is not the point. Optimize is not suppress. Optimize is take the right quantity. Try to target the right amount of additional fuel you may need on top of the contingency fuel. And target optimum. How to do this optimization? The first point is, as much as possible, plan this extra fuel. Then we will see you can also take advantage of all the improvements you have in your computerized flight plan today. These 2 points are really on your side, and they are basically initiatives you may have in your organization or with your flight planning providers. Then you must also, as a pilot, have confidence in the fuel computed on ground. You have also to be able to cope with unforeseen factors during the flight. These 2 points, I will speak about some Airbus innovations we will have and some subjects we work on to help you on this matter. At the end, the purpose is really to be sure that as a pilot, you really trust what has been computed and you really know what is inside your fuel computation. So when we say plan your extra fuel, it's not so easy. It's a question of data. So today we have a lot of data available, a lot of information coming from the aircraft, coming from the real flight conditions. And we have very good tools, or you have very good tools to do some big data analysis. So what is the purpose here? The purpose is to try to make a link between the extra fuel we may need on a route or on a flight as a function of the season, holidays, airport, route, weather. Try to correlate one route, one flight, one day at one time with the extra fuel we may need for the weather, for the SID, which is in use, the star, depending on the condition of the day, the taxi out allowance should be customized based on all these conditions. Statistics on actual fuel versus planned fuel, when the planned fuel is fully in line with the actual one, or actual one fully in line with the planned fuel, for which condition the actual fuel is higher than the planned fuel, and you can do that per route, per sector, time. And something which is quite interesting also, statistics on other pilot practices on this specific route for this specific day or specific slot of the day. So that's something which is not easy to do, but that will help to have a very clear understanding of the extra fuel need for a given flight. Then, as soon as this extra fuel is analyzed and planned, it has to be integrated in the flight planning computation, because that will help you to optimize your route and profile and optimize the trip computation. Of course, at the same time, you will be able to check the limitations you have on your attitudes, weights, speeds with this additional weight. Then you have also to take the full benefit of the options, the new improvements you have in your flight planning. So, since many years, the weather models which are used in the flight planning system are much better. The weather predictions are much better. The flight planning providers, you saw one example 2 days ago with Navtec, but they have now tools to predict threat, turbulences, storms, and that will help you to plan the routes that will avoid all these threats. And by a better management of threats, you can adapt the extra fuel quantity you have on a flight. Then you must have also confidence on the computed fuel. And here it's based on 3 points. Better aircraft weight knowledge, improved aircraft performance model, and then we will discuss about FMS predictions. So, better aircraft weight knowledge, once again, this is on your side. How to assume a better aircraft weight. The weight is basically inaccuracy on the weight, that's basically passenger inaccuracies. So it's true that most of the time we use average value given by the regulation or coming from surveys, but we all know that the passenger weight really depends on a lot of parameters. It depends on the route, on the season, on the holidays or not holidays, the type of the carry-on luggage also depend on that. What type of time is it? Is it a business flight? Is it more holiday flight? What about the season? So if you can customize or adapt your aircraft weight per sector, per route, that will remove some inaccuracy on your trip fuel computation. What about the aircraft performance model? Most of the flight planning on the market, not to say all of them, they are using pre-computed performance data. That's very efficient in terms of computation time. This is not always very, very precise because it has some conservatism inside. In Airbus, and here this is where Airbus may help you, we are working on a possibility, we are working on an offer to the computerized flight plan providers to replace all this pre-computed data by a real computation of the aircraft performance. And this real computation can be also fine-tuned for each tail number with some corrections which are better than what we know today, a single performance factor. Here we are working on the possibility to fine-tune aircraft performance per flight phase or with a fuel impact, drag impact, just at the end to be able to have a very accurate aircraft model in your system. Another area we are working on is for FMS performance database. So it's very interesting to work on the CFP, but if the FMS predictions are not aligned with your computerized flight plan predictions, it's not very good. If you go in the cockpit and if during the cockpit preparation, you see that the FMS reserves or extra fuel is not the same as the CFP, at the end, most of the time, that will induce some useless extra fuel. So what we are working on is a new possibility to customize the FMS performance database for each tail number with customization of the fuel impact, but also on the drag impact, a new tool to compute accurate idle factor to be sure that the descent profile will be the real one. So we will start this study on 350 for the first aircraft, and then we will see if we can do the same on other airplanes. So with this area here, we are trying to perfectly align what will be computed on ground, what will be computed on board by the FMS. And finally, the way to minimize impact of unforeseen conditions once you are flying, we are trying to provide some tools that will help you. So you saw the weather on board application yesterday with Maxime. We are also working on a real-time trajectory optimization tool that will help you during the flight to optimize the trajectory based on the different conditions you may have in front of you. So that's thanks to connected EFB. updated in real time, and helping the pilot to minimize impact of unforeseen conditions. Last part, finally. All these efforts are useless if you don't train your pilots on this point. So we at Airbus, we do not provide training on this subject because we think that this training is really linked to your operations, but we think that the knowledge is key on this subject. So you have to develop a training course for pilots. The objective of this course is really to give confidence to your flight crew in the fuel computation done on ground, give them the knowledge, how it is computed, and then we'll trust or not the CFP based on the conditions you give. You can share fuel practices all together and train them on tools for help for decision during the flight. So they say we do not have this training in our catalog, but if we may, we can suggest the content, or it should be not more than half of a day or 1 day maximum, but that's the point that should be covered or during this training. How the CFP computes fuel, what is already integrated, what about the extra fuel integrated, what are the assumptions for this extra fuel. Then the pilot will know if they need additional one. And as part of the training, you may have some workshops on fuel practices for your network, your specific network, per route, to exchange experience and events you may have on a given route, and to collect this data to integrate that in your fuel predictions. So to conclude, today the fuel remains something very important for your operation, in the cost of your operations. And one way to save fuel is to be sure that you take the right quantity. And the right quantity is not always the legal one, the one required by your regulation. You may need more on some flights. So the idea is how to find this additional fuel. So have a clear and adapted extra fuel policy, which is part of your computerized flight plan. Give confidence to your flight crew in the flight planning systems and train them on this flight planning system to know exactly what has been considered. Give tools, provide tools to decide when extra fuel is required, when you need more fuel than what has been planned. And finally, the concept is the extra fuel should be a question of flight, specific flight, not a question of who is seated on the left seat. Thank you.